Hello, in this video we are going to start talking about instance methods, and the first two instance method we're going to be talking about are the special init and string methods. Okay, so um, in previous lectures we said that class is the blueprint for some type of data. So does this look much like a blueprint to you? Empty class card? Well, it doesn't really, right? And what's the problem with um, that? For example, we initialize two cards here, 1 and 2, and then we set some attributes for those two instances of card. What's the problem doing it this way? Well, so we rely the code outside of the class definition. Okay, so these code are typically called like the user code or the client code. Okay, they're not part of the class definition. They're outside the class definition. So we rely on them to create the instance attributes for our class. So when we do that, things can go wrong, either intentionally or unintentionally, right? For example, in car 1, the client code did not set the model attribute, right? And then also what happened with this case is for car 1, it sets the year attribute is called year, but then for car 2, it does year built. So even though these two attributes are probably meant to say the same, refer to the same thing, they are named differently. So that's inconsistent, right? So really, instead of relying on the client code to do this, the blueprint, the class definition should, excuse me, should be responsible for creating a consistent set of attributes for each of the instance of the class, right? So, um, so the fact that a class definition should do things, what they actually can do are code that can be put in to instance methods. Okay, so what instance methods are? They are just functions. Okay, but they call methods because they are part of a class, but they're essentially functions, and they can be invoked by dereferencing an instance, just like the attributes. So let me just show a very quick. Well, I already wrote one here. So we start by saying, just define, just like a function. This is just a trivial example. So I call it full. I'll explain what self is. Well, actually, I have to explain what self is. But let's skip that for now. What this function does is just print out a simple message, right? It says, this function is called, or this method is called. And then I create an instance of car, and then I say the instance of the car dot and the name of the function. Okay, so it will invoke um, this this method that we defined here. So let's run it and see that it actually works, right? We actually successfully call the method of the car class. Yes, actually. So let me skip the explanation of self here because we're going to get into it in an actual function that we're going to define. Now, the first method that we'll study is called an initializer method, and it's actually usually for most classes it's also the first method we'll define for them for pretty much any class. So let me just write that. So instead of full, which is totally useless, I'm gonna say init. And then for now, I'm just gonna again just say init call. I'm not gonna do anything very useful. Now I am not going to called it explicitly. But guess what happened? When I run this, it's actually called. Okay, even though I did not explicitly call it. This is why this is kind of a special method. So what an initializer method is that it is automatically called when an instance of this class is created. Okay, it's called automatically. And also, now the next thing we want to know is, so what exactly is this self thing? Okay, now self is a mandatory first parameter of init and of any instance method. And the value and self is automatically assigned the instance that is just created. So there's a bit of a behind the scene magic there, but hopefully, I mean, this is just the way things works. So self here refers to the instance that is just created. Okay, so I'm going to do something, a few more things that's a little more useful than just print. I'm going to actually make self. This is the instance just created. I'm actually going to make it a make. We don't quite know what the make is, so I'm going to just say unknown for now. And then, okay, I'm going to actually copy this thing, and I'm going to say that also the model is unknown. And I'm going to say year, I don't know what year is, so let's just say 0. Okay. And then we can actually, why don't we print it out? Print out everything here. So there, oh, I misspelled model, obviously. And there, right? So let's run this. Okay, so I still have this message here. I can take that out now. But basically, yeah, I created all the attributes for this instance, which is this instance. And so I can actually access them and print them out after the instance is created. Okay. Yeah, that's how we create attributes for the instance. And that's how we read them back out and print them up. We just said these things are unknown because, well, we don't know what kind of car the user wants, right? We have no information. That's why we put unknown. Well, to make this a little more useful, we want the user or the client, when they create a car, they tell us what those make, model, years are. Okay, fortunately, we can do that. We because this is just a function. Method is just a function. It can take parameters just like functions. So we can allow the client code to pass in the make, pass in the model, and pass in the year. And when we are setting the attributes, we set the attribute make to the parameter make. We set the attribute model to the parameter model, and then we can set the attribute year to the parameter year. Now, here, then, you know, at a point where we instantiate an object of car, we can now pass in the make. Let's say Honda, make Accord, and then a year 1998. And then each of these values, they are assigned to the parameters, right? This is just works exactly the same way as function. And then they are stored in the attributes. So after creating this instance, the car, make, model, and year are hopefully, you know, what we just put in, Honda Accord in 1998. So let's run that, and there. That kind of verifies what we just said. Now, one very, very important observation is, I think you've hopefully noticed that, is this function usually the number of parameters matches the number of arguments, right? Now, for instance method, there's a slight mismatch. Okay, in the method definition, there are 4 parameters, but when you instantiate the object, you pass it 3 arguments. Okay, and that again, as we explained earlier, is that the parameter self is automatically assigned the instance that was just created, or actually this is the instance, right? It's automatically assigned the instance just created. So that's why there is no explicit value for self. Again, that's because self is assigned automatically or implicitly to the instance that is just created. All right, so now it's going to be very easy for us to create multiple cars. And where are my multiple cars? There. I'm a little too lazy to have to type all of these, and I'm going to just, yeah. So I'm going to create 2 cars. The first one is the Honda Accord, second car is the Tesla. And then I print out the information about both cars. Okay, so I run it, and there. So, I mean, compared to this code to the code that we had earlier, right? We didn't have to replicate, for each of these instance of car, we don't have to go attribute by attribute and create them one by one, right? We can just pass in all these values, and the initializer will create the attributes for us and storing the information that we pass in when we instantiate the object or when we instantiate the card. So that's hopefully makes sense, and it looks pretty cool. So just a few more words about init. Init is one of what I call dunder methods. And what dunders are is they stand for double underscore. Okay, because this is not very obvious from the presentation here, but there are 2 underscore before the word init, and there are 2 underscore after the word init. So it's really kind of double underscore. Okay, but anyway, so they're called dunder methods in Python. Okay, so this init method is really called the dunder init. Now these methods, this one method have very special meaning to Python, right? Like we just saw, it is automatically called after an instance of the class is created to give the programmer, us, a chance to initialize all the attributes for that instance. Right, that's what it does. Now, sometimes you're going to hear these methods referred to as magic methods. That's really not the right word according to the most of the real true Python programmers. So if you want to be a true Python programmer, call it dunder methods. That's a term that's accepted in the Python community. All right, so hopefully all that makes sense. Now it's your turn to maybe write a little code. So I think we kind of tried this in the previous lecture, but now let's create a point class and define its dunder init method, okay, which should take 2 parameters x and y, and then you're going to create two instance attributes x and y and store the parameter x and y into the attributes x and y. And then you can create several objects or instances of point and then give the x and y just different numbers. Print out each one of them to make sure they are properly stored. All right, so pause the video, go ahead and give this a try.